we've been talking about integration lately. And in the past, I had mentioned a distinction. I talked about signed area versus total area. And how did this kind of work? Well, if you have some picture that looks like this, you guys know that area above the x-axis is positive area, and area below the x-axis is negative area. So your picture would look something like this. This is sort of, if you were to talk about, I guess, signed area, you would be finding area that looked like this. And the way that you calculate this signed area is just you take the integral from a to b of f of x dx. So here in this picture, this is a and this is b, and this curve is y equal to f of x. And you just calculate the integral. The integral gives you signed area. Okay. Now, if I took this same picture, and if I wanted to calculate total area, what was total area? In total area, you don't allow the curve to drop below the x-axis. So let me erase this here. I think I could use a bigger eraser tip. Oh well. So what happens with the total area is you want to treat the negative area as positive area. So what we did was we said, oh, we could just take absolute value of f of x dx. And when you do that, the picture actually looks like this. Something like this. The negative parts get moved, get flipped. They become positive areas, right? So it's sort of like you end up with three pieces where every piece is positive. So this part got flipped. And that's captured by these absolute value symbols. Okay. So what does this have to do with what we were talking about? Well, we're always working with distance, position, velocity, acceleration, stuff like that. And the signed area is an example of something that we call net displacement. Thanks. Hold on one sec. Net displacement. So how does net displacement work? If I were to follow this picture, I'm saying walking this way. I'm kind of like walking forwards. Then I kind of walk backwards. Now I'm at the starting point. Now I keep going backwards. This is the negative area part. Then I come forwards. Then I come forwards. Then I come backwards. So let's say it worked all like this. The net displacement is how far am I from my starting distance point? That's the net displacement. The total area, that's what we call total distance traveled. So it's just the same thing we did before. We're just talking about it in terms of distance instead of area. So this is the total distance traveled. And in that case, every time I'm going, I have negative area, that's all treated as positive area, right? So I don't think I described my walking very well. So I think I need to be a little bit more careful. So I want to walk it off again for you because I should have made clear that, and maybe I should just copy these. Let me just copy these pictures again. I didn't explain it well. Let me do it over. Why do I copy these pictures again? because this time I want to remind you of the units. The x-axis is time, and the y-axis is actually velocity. So I think I described it wrong before. Okay. So let me walk it off. So this is, I'm standing at the left, the right edge over here. The positive part, that positive hump, I'm sort of increasing my velocity. I'm going faster and faster and faster. And then I'm sort of at max velocity right now, like right here. And then the downwards part of the curve means I start to slow down. So I'm still going forward, but I'm starting to slow down. And now here I'm at the intersection of the first curve and the t-axis. The part that drops below means I start to go backwards. And I go backwards with maximum velocity at the bottom of the hill. And then I keep going backwards, but now I'm starting to go, I'm slowing down. I'm slowing down. Okay. Then eventually, now I'm at the second intersection with the t-axis. Now I'm going forwards again. And then I start to slow down. So the net displacement is sort of the distance from my starting point to my ending point. And the total distance traveled would be all the steps I took going forwards and backwards. So that's really what's happening with this section. It's just the same thing we've been talking about in a different context. So going back to our worksheet, you can see that in this worksheet over here, we're working with the velocity function, just like what I had described. And when you wanted to find the net displacement, you just integrate the velocity function between your two times. Okay. When you talk about the total distance traveled, you got to integrate the absolute value. So the absolute value, integrating the absolute value is what often gives students difficulty. So what you need to do is you really need to break your interval up into two pieces, or not, maybe more than two pieces. You need to break it up into the places where the velocity is positive and the places where the velocity is negative. So the first thing we did was we found the point, the intersection point, which is at 5/3 seconds. And then we split our, we wrote down the definition of the absolute value of 3t minus 5. And as you know, part of it is positive and part of it is negative. And we got to figure out where each piece is positive and where each piece is negative. Then we sort of split our integral up into the two pieces. And by multiplying this by a negative, we ensure we're going to get a positive number. Okay. So I guess calculating this total distance traveled involves splitting your integral up into two pieces like that. All right. So